Okay. And do you feel hot? Have you turned it? But is it turned on? Is it turned on? Or not? Maybe you can check the AC. Okay. Okay. Anyway, let me continue. This is my name. Okay, if you haven't taken my course before, this is my name. You can call me Professor Iman or Mr. Iman or Sir Iman or anything. And this is my email for anything related to the course, or if you want to inform something to me, you can go through this, or to the Moodle also. But sometimes Moodle has a few minutes delay. But here I think it's more convenient, it's faster, just to go through the Gmail. So I think some, if you check, I think many of you using tablet, right? iPad for your daily works, right? But I don't know. If you check the external monitor, I think since the last update, it is not working. Is it correct? Have you checked? Maybe you have the dongle, the adapter, and check using any monitor. For me, it's not working. You can check. Maybe for some monitors work with, like for this one, it's not working at all. So I need to use connect to the MacBook and its screen mirror to my iPad. So I don't know. Just to let you know that it's not work as usual. And even I think the HDMI is not working. In other class, HDMI is working. So I think I need to inform the school to let they know that maybe it's the cable, or maybe the cable has problem. Okay, anyway, let me continue. Have you passed Calculus 1 course? Can you let me know how many you failed this course? I just want to know the roughly, just to see where we are. Okay, I think around 1/3 or 20, maybe 30%. I think 20 to 30% of the class, right? Okay, why I'm asking this, because in Calculus 2, all the things you learn in Calculus 1 will be, so you need those, either the knowledge, techniques, all the things in Calculus 1, I will assume you understand. Okay? I will review a little bit, but I will not review too much. Okay? So so you need some techniques from Calculus 1. And I think same textbook. Okay, without this picture. Yeah, James Stewart. And for those of you who are not familiar with Wolfram Alpha, I'm suggesting you just to check Wolfram Alpha. This is, I think, computational tools for, I think, basically for mathematics. So any question related to calculus, mathematics, you can check Wolfram Alpha. wolframalpha.com. Okay. I suggest you check at least once, okay? Because last semester, at the beginning of the class, I tell you about this. I think a few students check, but mostly they don't check and they don't really care much about this. Okay? This is really powerful. For any straightforward questions, you have a function, you want to differentiate, you want to integrate. This can compute easily, at least to check whether your answer is correct or not. Okay? So Wolfram Alpha. For graphics, you can check GeoGebra. Both are websites, so you can access through your phone or through your laptop or tablet. Okay? So all can be accessed. And both are free. Before Wolfram Alpha, the free version is getting you the exact answer. If you want to know the whole steps, you need to pay. Okay? But at least Wolfram Alpha will give you a hint at the beginning, like what you need to do first. So you can try and guess, and then maybe that is for your exercise. Okay? Or even, I think some of you are familiar with the AI. It also can be done. I think it can be done flawlessly, correctly, for questions that is straightforward. If the question is a little bit confusing, the AI will also confuse and will give you maybe ambiguous conclusion. So I think that is still to work on that. Okay? And I think Wolfram Alpha also, if you check, I think the ChatGPT, they also have plugins for Wolfram Alpha if you check. And I've tried several times. For calculus straightforward question, they're all correct. But again, that is just tools. The important thing is the concept. So you need to understand the concept. You cannot just asking and then copy paste the whole thing without understanding anything. Okay? So if you have other courses that is like let you do that, okay, I assure you that the professor will know, oh, this is just copy paste. Okay? Okay, so Wolfram Alpha and GeoGebra, I think these two, for me, personally, is the best. There are other graphics websites as well, like Desmos, and I think, if you're familiar with MATLAB, it's also good. I think it's also good for computation. Okay. So that's textbooks and some resources that is important. Okay, what you need to do and to know and prepare. Okay, this is just some suggestion, advice. Okay, basic math and calculus. I think you need to familiarize all the formula. At least if you see like derivative, like chain rule and so on and so forth, I assume in this course you are familiar with this. Okay? So another thing is integrations, substitution method, integration by parts. These two techniques most known and most used for solving the integrations. Then is still we are going to use that in calculus 2. Okay, so I think that is just an introduction that you need to know. And then, okay, you need to spend some time for review. Okay, any techniques that you have before. And if you want to have a tutor, I will let you find by yourself. Okay. So find someone who are perhaps, I think for tutor, he or she needs to be having at least A in the course. But previously he has got A. So if he or she has a free time and want to be a tutor, then you can ask him or her, apply through the learning center, and then fill in some documents, and then you can like form your own group. Okay. Last semester I tried to help by combining some students, but I think I will let you just do it yourself. Find someone who are excellent. If you have like seniors who are perhaps has a good explanation and he has at least A in the course, I mean in calculus, then she or he can apply. Okay? And practice regularly. I think it should be like a cliche, but important. And then I think course materials that I previously mentioned, like Wolfram Alpha or GeoGebra, you need to check. Okay. Oh, by the way, the GeoGebra also has a resource. So if you check GeoGebra, you can check resources and you can find any topics. For example, this semester we are going to learn parametric equations, or we will learn the polar equation. You can check many resources because the graphics in this course will be much more complicated compared with the calculus one. Calculus one we deal only with single variable, right? Single variable calculus. I think it's not working. It's working, but it's not. This how is not good. But now in this semester we are working with multivariable calculus, which means that we are not only dealing with f of x, but we may be dealing with function of xy or xyz. At least xyz, that is our goal. So it's not only a single integral, we are going to have double integral, even triple integral. Okay? And I think that is why drawing the graphs will be much more difficult if you are perhaps difficult to imagine in our mind. So this GeoGebra will help you to describe. GeoGebra, most of students didn't know that it can also project three-dimensional graphs. You can do that as well. I think GeoGebra also has tutorials on YouTube that you can follow, how to like sketch the graph and everything, and how to use the 3D sketch, at least for drawing the three axes, x, y, z. It can also be done in GeoGebra. Okay, so at least you need to try. Okay, I will try maybe in the middle of the course. Okay, to show you what it looks like, because sometimes I also have a difficulty to draw the graph. And then seek resources and help. Okay, so if you have a difficulty for some, perhaps your academic, like your topics in class, or anything that I can help with, just let me know, and then we can try to discuss and maybe have a solution for you. Especially if you have a difficulty for some topics, Like if it's not academic, maybe you have difficulty in your daily schedule and everything. Also, if you want to let me know, it's okay. Like sometimes some students, oh, I have a competition, blah blah. Oh, I have a schedule on here, blah blah blah. Just let me know. Okay? So I know your situation. Okay? Because usually in other courses, students came to me like 1 week before final exam. Professor, I blah 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 blah. And then you just tell me like, is it make sense? Like he has a problem to begin with, but he told me like 1 week before final exam. It's not good. As soon as possible, like if you have difficulties, let me know. So I know your situation. For example, there's one student who has difficulty because his father is in the hospital, so he had to tend his father because the father has a cancer. And he let me know like as early as possible. So he want to let me know that he might not be able to come to class every schedule. That is okay for me. That's okay. So I know his schedule and I can arrange the schedule for exam in different day. That is I know. If the students come to me, like he just telling me like this semester I work at a part-time blah 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 blah, but he came to me maybe like 3 days before the final exam. That's not good. Okay. So you, if you want to know whether you can be accepted, just let me know as soon as possible. Okay. So any reason is okay for me. Any reason is okay for me. I will not like having like a really hard restriction. Okay, you cannot do this. It's okay. Even if you want to sleep in class, it's okay for me. Okay. Like 5-10 minutes is okay for me. After that, you refresh, get up, and then continue the class. It's okay for me. Because if you are sleeping in class, that means that your body needs rest. And if you try to force out your body, you will later at the end of the day, your body will affected by burnout, and it's not good. For mental, it's not good. For your physics, it's not good. So that's why I will tolerate if you want to sleep in class. But you need to catch up. Okay, you need to catch up. Okay, that's the one thing here. And scoring. I think last time, I had some errors in my system, so some of the attendance is missing. Okay, so sorry for that. I will try just using the at least the Google Forms for attendance. And if we have like usually I will have a feedback question at the end of the class. Not all class, maybe some classes I will have some feedback questions like a mini quiz. This will be affecting the activity. Okay? So perhaps like attendance maybe 5, 10. Okay, but usually I divide by 2. I will see at the end of the day what is the average. What is the average of the class? Okay, sometimes it will be important to raise the decimals in your grade. Okay, so quiz 25, 20, 30. Okay. Quiz perhaps at least 3 times. We have 3 times quiz. If we need more, maybe 4, but I think minimum maybe 3 quizzes. And then midterm, after some topics, I will announce when we will have midterm. Usually it will be the same as the schedule by the school. If not, maybe delayed a few days or 1 week. Okay. Final, hopefully it will be the same, so you can have a good break for the summer. Right? The summer, I think some students already prepare the tickets, right? It's cheaper, right? Okay, I think that's the scoring, and this is what we have for calculus 2. Integral applications. This is not really that much. Only 2 subtopics: the arc line and the surface area, and then parametric and polar. This is actually, the technique is the same with calculus 1. The difference is we are using different perspective. First is parametric. We usually use another variable, usually t, and polar. We shift or we convert the xy into polar. Okay, the polar. And we are going to see what will happen. And then sequence and series, and then factors and geometric space. This will be very short. So this is just to show you how we write the factors and some of perhaps some phenomena in factors that might be comes up in our course. So not really that much. I think in one meeting maybe we will finish the factors, or maybe 1 or 2. Okay. And vector functions. Also, this will be very short. This is just to show you that in the vector world, we can also use calculus technique like differentiations and integration. Okay. But using the vectors. Okay. So this 2 is actually additional resources for the last 2. So this 2 will be very much focused. So actually our course, the calculus 2, the emphasis will be on the last 2. So partial derivative and multiple integral. So this will be the main topic for your final exam. So your midterm perhaps is 3 or maybe 4, but I think vector and vector functions is not that much. So in terms of difficulty, I think it's much more heavily depends on the first 3 and then the last 2. Okay? Okay, I hope you get to the point. Okay? That's the short syllabus that I can show you. Maybe before we start the course, is there any question? Okay. So I will start the course by.
Are we using calculators for classes?
Okay, for calculus 2, I will allow. Okay, I will allow calculus. Okay. So I hope it's okay with you. That means the question will be it will be interesting. Okay. Okay, I think we can go through the course. Okay. Yes? Yeah, TA, yes, we have. It will be different from the last one. Your TA will be Celine. Celine, do you know? You know? Okay. She cannot be here today, but she will be in class later. Okay. I think in IB 502. Okay. You know all the pictures I created with AI. I just try like, oh, interesting. Okay. Move to the okay, so we'll start here by saying that calculus 1 is single variable. We say this is single variable calculus. And calculus 2 is multi-variable calculus. So if we say single variable, so the functions or the independent variable is just one. Okay. Let me check. Okay. So perhaps this is usually defined as a function of x like that. In calculus 2, at least we are going to see two variables. Okay, at least for chapter 14 and 15, the partial derivative and multiple integrals, we are going to see multivariable calculus. Okay, but before that, we are going to see the parametric and then polar, and actually, the arc length is supposed to be in last semester. Supposed to be, but since we don't have time to catch this up, so I will try my best. This week we are going to finish arc length and surface area. So what is the arc length? So imagine the left picture here. So you have a function, a random function like that, the blue one. Okay, that is your function. Ignore the red line, ignore the left line. So the functions we want to know, like the distance. We measure this, how many units. So we want to know how many units. If we want to measure this point, and then we go through this blue line, how long? Okay, how long is that? Now the idea within this picture, we give them another point, several points, okay? And then we connect all this red line. Okay? We connect this line, okay, all together. Now if you see here, there are several lines here that can be possibility. But it says we start first from this one. The gap is really huge, right? It's quite wide, okay? But if we cut and adding more points, so add 1 point here, okay, we get here. We add more points in between these endpoints. We add more points. Oh, we get that line. And you see the gap between blue and red is getting smaller, right? It's getting smaller. And eventually, if you get more and more points, you see that the red line is getting closer to the blue line, okay? Which means that if we cut as n
getting closer to, or getting larger and larger and larger as possible, the red line becomes smooth as blue, close to blue, right? Okay. So we can say that actually from this notions we could get the L, or L is the length. So length L, if we take the limit as n is getting larger, and we add all the segment point, and we add all the segment point, we are getting closer to our goal, right? So we are going to have, so let's say this is from the first iterations until n, and we are going to take this. This means the distance from pi minus 1 to pi, which means this one, okay? Or any terms that is related. But for this one, it is this one. Okay? So if we cut and more and more points, then we are getting closer to our goal, that is measuring the length in this blue curve. Okay. So we call the curves smooth if small change in x produce small change in f prime x. Now if we let the point, let's say the point I will draw here, okay. Now if we take, this is a delta yi, and this will be delta xi. So let's say we have this delta x and delta y as a component from the curve. Okay. Now the distance, okay, if you remember how to calculate this distance, the red one here, is basically by taking the square, right? Pythagorean theorem, right? So we take this equal square root of this square plus this square. So let me write that. So distance from pi minus 1 pi is equal, let's say this is xi minus xi minus 1 squared plus yi minus yi minus 1 squared. Okay. Or simply we say this will be delta x squared plus delta y squared. Okay. Now taking the mean value theorem, remember the mean value theorem is basically saying that there will be exactly a point that is between two endpoints, okay? And it will relate it to the gradient. Okay, it will relate to the gradient. So I will write here the implications is, let me just, I think it's not really good. So implication is fxi minus f xi minus 1. Okay, for xi minus 1 to xi, this will equal to the f prime of xi. Let me write asterisk, which means the xi asterisk is in between xi minus 1 and xi. Okay, it feels really rigid and ambiguous, the definition, but let me write the definition first, and then I will let you know how to get this by intuition and really fast. Okay, just bear with me. Okay, this is xi minus xi minus 1. Okay, so basically this is the delta y. Or we can also simplify it. This is delta x. Or perhaps this is not xi, just delta x because it's a fix. So since we have delta y is this, okay, then we can apply this delta y into our system here. This is delta yi. Okay. Let me arrange this first to make it more clear. There. Let me erase first to make it clear. Okay. Then we can write this will be delta x squared plus, we change the delta y with the f prime. F prime xi asterisk. Asterisk means it can be in any points in between. Okay, it's called the sample point if you remember. So delta x squared. Okay. Now we factorize the delta x, right? We factorize the delta x. So delta x can come out. So we can have, let me write different color. So this will be 1 plus f prime and this will be delta x. So delta x factorized and then we are squaring root, right? So by definition, then this is the L, or we can say that the limit of n of the distance is equaling that. Forget the limit, sorry. So, or let me write this, go here, and then let me write again limit. Now remember, the expression of the limit and the sum, it means that we have something random, the functions, we cut, and we plus the cut. So the summation of that limit is, we call that integral. Right? So we can say that this is integral based on the endpoints that is defined by the x. It can be any points, but we start by taking that into A to B. Usually we say that A to B. So the arc length formula will be let me write here. If f prime is continuous on point AB, then length of the curve y equal f of x from A to B is, we call L equal integration from A to B 1 plus f prime of x, and don't forget this is squared, and then dx. We can also write in terms of the Leibniz notations, like this. 1 plus dy over dx squared dx. Okay, that's the arc length. Of course, this is for a function of x, but sometimes we can have a condition that is function of y, but still single variable. For example, if we let x equals like function of y, then this will be dx over dy. It's the same, but we split the variable. There are, however, okay, so instead of getting all this done using mean value theorem, etc., we call this is the official definition for arc length. But to recognize the formula of arc length, we can use intuition by looking at the graph, especially this graph here. I have prepared here. So let me make it a little bit bigger, going up. So basically, what you need to do is Pythagorean theorem from this triangle. Okay. Because if we let this delta s as smaller as possible, smaller, let me write here. So based on that, okay, let me write first here. We have such ds okay, we start from that Pythagorean and then we arrange. I will factor out the dx. So this will be 1, this will be dy over dx. Okay. Okay. So we get something that is familiar with our formula, right? So this ds, like if we let this as our differentials, we can integrate these to get S. So we can integrate. And depends on which part of our integrations, but we can always do integration, or let me write S is let's say A to B. Okay. And we can get the same expression. So I think the best way to get into the formula, you can draw any graph, draw 2 points, and then let's say you have like a small distance, and draw a triangle, and let that triangle as a, you can use delta or D to measure that is, assuming that is very, very small. Okay? Assuming that is very, very small, it's very small, which means if this is very small, the gap between the red and blue are getting smaller. But of course, if you are getting smaller, you can see from your paper, right? So just draw like usual, but assuming that is very small. Okay? Assuming that is very small. Then through some concept in calculus, we take that using limit. Then this can happen. Okay, so we have done this. But remember, this is not the official definitions for our class, but this is a good way to retrace the formula itself. So you don't really rely on your memorization of the formula. Okay? You can just always draw the graph, make the triangle, and then using the Pythagorean formula, integrations, and you get the formula. Okay? Okay, any questions so far?
Can you show the part with the taking mean value?
Which one? Mean.
With taking mean value.
Which one?
It was before.
Oh.
I just zero.
This one?
Yeah.
Okay.
What this star means?
It's called the sample point. It means that it can be anywhere.
Ah.
It can anywhere in between. So remember, if it is a function of y, then you can just flip. Okay, for example, here it can be dx over dy, dy. For example, like that. Okay. I think we can move to some examples, okay? Some examples. I think I will just using this part here. Okay, let's continue. I would like just to see maybe 2 questions or maybe 3 questions, maybe 2 questions first. Maybe number 10 and 13. Okay, and then if you want to check the rest, you can check by yourself. I think some students already checked the questions. This is starting from very simple and then getting a little bit hard and difficult. Depends on your understanding in calculus 1. Some can be solved just using by regular substitution, integration. Some maybe, I think mostly you can substitute. Yeah, we can try. Okay, we can try number 10 first. Okay. Number 10, we have a functions x plus 4 with a power of 3/2. Number 10, okay. So first we can write, let's write the function first. Start from 0 to 4. So perhaps we can get the first derivative, dy dx. So this will be 3/2 x plus 4, and 3/2 minus 1 is 1/2, right? So that is the first derivative. And then we can square it. This will be 9/4, right? 9/4. This is x plus 4, right? And then if we plus 1 on the left, plus 1 on the right, we get the sum of the formula, right? So the formula we can write again here, that this will be from 0 to 4. This will be 1 plus 9/4 dx. And we solve a little bit. So solve this 9/4x plus 9. So it's 10. So it's 10 plus 9/4 x dx. I think we can directly integrate, right? So this will be, imagine that this will be the 10 plus 9/4, like that. So if we plus 1, that will be the 3/2, right? So 2/3 So 2/3 and then multiply with 4/9, right? 4/9 is 8/27, right? So 8/27. This will be half plus 1 is 3/2, right? And plug in 0 to 4. Okay. Now that's why I'm giving you a chance using calculator in this class. You can check your using calculator. So 4 so maybe if you want to force this out, this will be 10, right? Oh, no, 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 no. Let's try 4 first. 4 is 19, right? 19. 19, 3 over 2 minus 10, 3 over 2. Okay, for whatever number, that is how we get the process. If you have a difficulty, you can, I think you just take the substitution. Just u, blah, blah, blah. And then the u, the x, change it all to u, and blah, blah, blah. I'm skipping some process here. How do I write? I'm skipping some process here. So if you want to check, you can substitute this using, let's say u is 10 plus 9 over 4x, right? So du is 9 over 4 dx. And then you exchange this dx is 4 over 9 du. Right? So 4 over 9, you multiply with this 2 over 3. 4, 2, 8, 9, 3, 27, right? I hope you can try this. If you are not convinced, you can try and then while you are reviewing calculus 1. Okay, any questions? Okay, right? It will be fine just using substitutions and substitute everything. You're going to substitute, like for example, x is 0 to 4, and you're going to substitute using this u. It's also okay, right? So it will be 10 to 19. 10 to 19 will be appear here, right, at the end, if you substitute u. For example, let me just give the alternative for this u. Okay, so x0, u will be 10. X is 4, u will be 19, right? So this will be 10, 19. This will be u, and then multiply with 4 over 9 du. Okay. And 4 over 9, I will factorize. This is u du, okay? U half, sorry. And then u half becomes 2 over 3. 2 over 3 u, 3 over 2, okay? Du. Oh, sorry. It's already integrated from 10 to 19. Okay, so 8 over 27. This will be 19. Okay. Yeah. Yeah, this is actually for
from the substitution of the from here. U power of half integrate 1 over 2 plus 1, 3 over 2. We need to add 2 over 3 in the front. So 2 over 3, U 3 over 2. If you derive this, it needs to be exactly this one, right? So it's 3 over 2 cancel out. 3 over 2 minus 1. 1 over 2 is the same, right? Get it?
Okay, maybe one more question. Number 13. Yes? Which one?
The whole answer.
This one?
Yeah, basically, find you have y, find dy dx, take this square, plus 1, and then bring all that into this formula, and then just integrate. Simplify and then integrate. In the middle of the process, sometimes you will get, mostly at the early questions, there will be mostly substitution techniques that you need to apply. So substitute, eventually, if you know how it works, you can skip the process and go directly here. So it means that this is something, right? I'm usually saying that this is something that we can apply into one simple variable, right? The variable can be anything. And then this is half. So every variable with half, if we integrate, it will be 2 over 3, something, 3 over 2, right? That something is having 9 over 4x. So to get x, we need to multiply with 4 over 9. So that's why I just took over 3 and 4 over 9. I multiply and get 8 over 27. It's actually simplification of this. Okay. But if you want to write the whole thing, you can substitute with some u, get the u, and you can substitute dx, put back here, and then you get this du. Okay. 4 over 9 du. And don't forget, when you change from x to u, you change also the endpoint. From r plus 1, if you substitute from x to u, or from x to any something, then change the number also. So change the number from 0 to 10. Where do we get this 10? Is basically we take x to here, 0, so 10. It's 4, 19, right? Okay. So take integration from 10 to 19, and we get this. U half, multiply 4 over 9 du. I will factorize 4 over 9. And we have u with power of half, which we can integrate easily, right? 1 over 2 plus 1 is 3 over 2. And you need to multiply the 2 over 3, okay? And then you get the 2 over 3, u 3 over 2. That's the integration from this. And multiply everything, substitute the 19 and 10 to u, and you get this, the same. Okay. I think just take slowly for the substitutions. I think you will get everything. Okay, you will get everything. So as long as first you derive, take the square, and just plug it into the formula. That's it. But the mostly what will be difficult is when you try to simplify. Sometimes there will be something like this. It's not really that long. But sometimes you need to find out because the problem usually in the R plane is the square root. Sometimes you need to find a way to remove the square root. Sometimes. Maybe later I will see if we can have some example from exams related to the R plane. Sometimes there are some tricky problems. If you are not simplified enough, you will stuck here. Sometimes I will try. Maybe on the next class we are going to see another example. But now let's try number 13. Number 13 is the x cubed
over 3 plus 1 over 4x. That's the function. And we have from 1 to 2 for the endpoints. So again, the first thing you need to do is finding the first derivative. Okay? So this is like reviewing your calculus 1, at least the first derivative and then the integration. Okay, this one. Can I turn the page or still write this one? Okay. Okay, let me add the page. Let me copy the question. Oh wait, wrong. 13, right? Okay, we can derive this one by one, right? Do not combine these two, okay? So just let them split one by one. So first, we derive x cubed over 3. So we be 3x squared over 3, or we can say it's x squared, the first one. And then what's happened with the 1 over 4x? We can think this as 1 over 4 multiplied with 1 over x, right? So let me write on the right side. So this will be, let's say we have this and this. The 1 over x is just like x minus 1, like that, right? If we derive, we're going to see negative x, negative 2, okay? Or we say negative 1 over x squared, okay? So if we take the derivative, this will be negative 4 over x squared, okay? So this part is become negative 1 over 4 x squared. Okay, at least the first step. Now I will write 1 plus dy dx squared. So I will take the squared. Okay, I will take the squared. It seems a little bit long, but actually, if you write slowly, you will see the pattern. Okay? And this is, I think, most the tricks that for many exams among universities in Taiwan, I see the same patterns. Okay? So this 1 plus, and then this will be, if I take the squared here, this take the squared here. So let's just one by one, using the quadratic equations, you can expand the equations. So we are going to see x with power of 4, and then minus 2 multiply x squared with 1 over 4 x squared. So this will be cancel, and then 1 over 4 and 2 becomes minus 1 over 2, right? And then plus 1 over 16x 4. Okay, so just take it slowly. And now we can take this 1 and 1 over 2. So 1 minus half is positive half, right? So let's write the same thing, similar, but with a positive. So we have and now what's next? What's next? we're still not having the square root, right? So it should be square root, but what will happen? How to solve? Now this is what I say, this is, usually this will be the pattern. So the pattern is, you see the squared first, and you see the plus 1. Usually when you add the constant, it will be another form of some expansion that can be simplified into quadratic. So this is another a plus b squared. And that is usually how to take down the question. And mostly, many tricks for exam can be solved through that trick. Right? It's not tricks actually. You see, this is 4, this is 4. So maybe we can see that we can relate this to something, because you see when we have this, it can be this, right? So what happens with this? This is the same thing. So let's just take plus and then take the square. Same with this. So we can do the same, right? So we can do the same thing. So this will be x squared plus squared. Okay. So you need to be able to see the pattern. Okay. So when you have this squared, we can easily take the square root and cancel this two. Okay. So let's write again here. So let's say this is taking the square root and then taking the square root. Okay. So we get the L. It's from 1 to 2. And we can just write x squared plus 1 over 4 x squared. And then the x. And the rest is integrations. Okay. I think we can easily convert this, right? So x squared is 1 over 3 x cubed, right? Integrate. And 1 over 4 x squared is from 1 over 4, 1 over x squared. It will be negative, right? Negative 4 over x, right? Yeah. You can check if we derive, it will be brings back the original. And then plug in 1 to 2. So this will be 8 over 3 minus 1 over 8 minus 1 over 3 minus 1 over 4. This will be 7 over 3. 1 over 4 minus 1 over 8 plus 1 over 8. Right? (56) plus 3, 59. If you just stop until here, okay, you find them. But I think since I allow you calculator, just type in your calculator. Any questions so far? One. Oh, wait. Do I miss out one? Oh, we already plus. We already plus, right? 1 minus 1. Yeah, already plus. Yeah, we already plus. 1 minus half is already here, so it's already changed. So this whole thing is already 1 plus dy dx. Okay?
So normally the pattern would be that if we find the components.
Yeah, the quadratic pattern. To remove the square root.
But I mean it's quadratic.
Yeah. So usually to remove the square root, we need to find a way to make the equations quadratic. So we can cancel the square root. Okay, any other question? Yeah. What is it? Okay, I will continue first, just an introduction to the surface area. And next Thursday, we can have more examples, okay? So that's arc length, okay? And now is surface area. Okay, I hope you don't mind. The surface area, we are going to use the same exact arc length equations with some additional terms. So here, what's the surface mean? Let's say this is the function of x. And then we rotate, like you did in the volume, right? So rotate, but we want to know the surface area of this. Okay? So the whole area that is covering this shape. Now how to find that? The first thing we need to observe is what kind of shape this has. If we take some, maybe we split this in small sections, we can have like a small band, right? Small band. So that small band, we can say that if we imagine that it is going to be bent like this, and this is coming from the cone, and then cut the cone, like from here. Well, perhaps if we take the cone, and if we spread out, and we have this, the same cone we cut, so we can have the bigger cone minus the part that is missing. Then we get this, right? Okay. Now we can write. Okay. Now why this is important? Because the shape, if this is quite small, if the length is quite small, it can fit with this, right? So imagine that this small band here. It's like a small part from this cone, right? Okay. So this is how we approach the surface area from any random function that can be rotated, and then we can get this kind of shape, and we can have this as our reference to get the surface area. Okay? So let's start by taking these two. So take that and then we can approach the formulations. So what is the formula for the cone? The formula of the cone is, let me write here. We call this sector, okay? Like a pizza, okay? Like you have a pizza, you slice, and that is the shape, right? We call that is the sector. What is the area of the sector? It's half L squared theta. Or if you want to naturally define the area, the whole area is the circle, right? We have the theta, which means that this is theta over 2 pi multiply with 2 pi. Since the radius is L, I'm going to write L and then squared. Okay, and that's why we get half L squared theta. Okay? But what is theta? So the theta itself is equal to the circumference, right, divided by L. Or if you want to say the ratio from this, we can also write this as a reference. And then we can substitute this into here, which we get the area as pi r L. This is a surface area for cone. And I think some of you maybe remember that this is the surface area for the cone. That's the whole surface. Okay, now we have another shape which we can construct with the same surface area with different radius. Okay. So this area comes up with the bigger one, which is the cone for the radius R2. So this we need to add L with L1. So L plus L1 minus pi R1, which is the L1, like that. We can factorize pi. And then this will be R2L plus R2L1 minus R1L1. Or we can factorize again L1 inside. So pi. This will be R2 minus R1. L1 plus R2L. Okay. So first we get this, and then second, we can have the ratio from this triangle. So let's say this is triangle. First is base R1, the second is base R2. Okay? And each one of them has the diagonal L1 and L. So we can take the ratio for this big triangle and a small triangle. So let me write here. Triangle ratio L1 over R1 equal L1 plus L over the R2. And we can cross multiply. So R2 L1, this is R1 L1 plus L. And we can simplify more. So R2 L1 minus R1 L1 is R1 L. Or R2 minus R1 of L1 is R1 L. Okay, since we have this, and this is the same with this one, so we can substitute with R1L. Okay, substitute R1L. So, right here, substitute there. So A will be pi R1L plus R2L, or pi L R1 plus R2. And we set up some definitions. We set up that if R half R1 plus R2 is the average radius of the band, meaning the shape, we call this is the band, right? Maybe here, this is the band. Then the area for the surface of the shape of the band. So let's just change the half R1 plus R2, or R1 plus R2 becomes 2R. Okay, so let me write here. So 2R is R1 plus R2. So substitute back to the equation. So we get that the surface will be 2 pi RL, and this will be our approach for this surface area. Okay. And actually, the conditions that can be set up, if we remember, it's the only way that we can set up this is by looking at this L. That L, if we zoom out and see what it looks like, it's actually the same L that we discussed before. It's arc length. Okay. So this L is actually the arc length. So later at the end of the day, this L can be defined through the arc length. So you need to have integral. So this is how we approximate. So and then similarly, the more points that we have in between, the shape will be getting closer to the real image. If maybe the points are maybe not too many, the shape will have some gaps, right, between the red color band here with the real blue shape. Right? You can see that there is some gap. It's like what we have in the arc length, which we have the gaps in between, right? In between the red and the blue. Now also the same. The shape has also gaps. So let me just write down here. So similarly, what we have before, we can apply here, which means that the surface area can be approached by 2 pi. Now the radius is this radius, okay? You see, this is the circle, right? So this is the radius. So this is the radius that we say here, and we state that this radius is this pi. Okay? And just to make it correct, let me just write the radius as y I minus 1 plus y I over 2, and then this will be the distance, pi I minus 1 pi I. And this basically, this is the arc length. And the same thing what we have, this one, we can make it averagely as its function. As its function, because each point it will have different radius, right? Okay. So we can have this approximating 2 pi f, and let's say xi, and then adding star like that. It means that it can be in any in between. And then this will be the definition from the arc length. And then, similar like the arc length, when we have much n, and when n is getting larger, it means that when we slice it more and more, we could take it into our limit concept and make it in integral definition. So, we can take the limit as n getting larger. And by definitions, it will be integral from a, b, 2 pi f of x and that is one way to define. Okay. There are some restriction on this formula, depends on how the shape will be. So it can be like this, or it can be in the vertical axis. There will be some differences. And for instance, I think let me just stay here first so we can write first. I will see, we're going to see how to apply, and maybe next Thursday we can have some review on the surface area, and maybe if you have any question on arc length, we can discuss as well. Okay. Actually, if you just stick around, just using the 2 pi RL, just use this one. It can be defined with anything. So R depends. Is it function of x? Is it function of y? And then L, what will be the arc length? So you could decide, is it dy over dx or dx over dy? As long as it is correct with the picture, with the graphs, you are getting a correct answer. Okay, I think this will be for today.
I didn't like quite understand what you mean with this two lines, like with our with air. from this part.
This part?
Yeah.
Okay. So we get this is the surface area.
Yeah.
And what is the L actually? The L is actually something that is in that part, right? So if we see from this, which one is the L?
The red part.
This one, right? That's the arc length.
Yeah.
Basically, this is arc length. That is what I've been saying. So this L, we can describe within the arc length.
Yeah.
And this R is this, right?
Yeah.
Okay. So this is yi and this is yi minus 1. So the average is this. Or we can say that averagely, we can say that the radius will be depends on where the x, right? So when we change the x, the radius is changing, right? So the radius is a function of x. So that's why we can write function of x, the radius. So maybe before I end officially, this is just a shortcut. Every time you have like this, the difference is this will be the y, like before. This is y, right? And if you have this, then this will be the x. And the outline will be the same. And how you calculate depends which preference. Sometimes it will be easier if you are using dy over dx. Sometimes it's dx over dy. Depends on the function, depends on the case. Okay? But most of the time, the difference between these two is just in the radius. Okay? The rest is the same. And the way you decide which one is which will be, I think, will be important. Okay? Because sometimes maybe one way will be a little bit longer than the other one. Maybe that is how you decide. But basically, they are both the same. The difference is the radius. Is it y or is it x? Okay. The example before is this one, y, right? But since y is function of x, we can change y to function of x. But since it's function of x, the logical sense is the dx should be ended with the dx, right? Okay. So that's how we choose. Okay. I think more to come is how to apply in the examples. Okay. I think that's today. We don't have attendance. I think this week I will not prepare attendance. Maybe next week I will start the attendance. Okay.
So
Yes.
last question. So the last slide, there was like grouping, like function of x. If you only want to be just like taking the x.
I think like for example here, the target is taking
Okay, so it will be there.